Hello friends. So in this particular lecture, we will be seeing the external irreversibility in case of Rankine cycle. So when we say external irreversibility, so that is because of the heat transfer. Now you must be wondering that why it happens because of heat transfer. Whenever there is a difference in temperature, whenever there is a difference in temperature, the heat flows. Okay, and this the more the difference in temperature, the more will be the heat transfer, the faster will be the heat transfer, and the faster the process will be, the more irreversible the process will become. So you must be remembering that in your thermodynamics course you might have learned that if the heat transfer happens at infinitely small temperature difference, then only it can tend to reversibility. So what happens in the furnace, the temperature is huge, round about 1300 degrees Celsius, close to this, or 1250 to 1300 degrees Celsius, in between this. So this huge temperature inside the furnace, there is a few gases, and this has resulted in a heat transfer to the water. And the water normally boils around, if let's say the pressure is not very high, then let's say the boiling point of the water for the particular pressure is about 500 degrees Celsius, let's say. So 1300 degrees Celsius and 500 degrees Celsius temperature, it is a huge temperature difference in the economizer portion. And similarly in the evaporator, because temperature is not going to change in the evaporator, and then again in the superator it rises, but again it not up to the same value. So there is a huge amount of irreversibility. The same thing happens in the condenser side also. So if I draw a simple Rankine cycle, if I draw a simple Rankine cycle, like this, let's say it is entropy, this is temperature, and this is your okay. Now, now if I view it from the boiler side, then the water converting into saturated liquid, then that convert into saturated vapor, and finally superheated vapor. That is happening because of what? That is happening because of the, oops, sorry, because of this one, flue gases. So flue gases are basically transferring their energy to the water for phase conversion and superheating. So flue gases, let's say, enters at A and exit at B. So here, if you look, there is a huge temperature difference at each and every point. Okay, so this temperature difference will cause the external irreversibility on the boiler side. What about in the condenser side? Here also, if you look this thing, then here the steam is getting condensed. That means steam is losing its energy so that it can get converted into saturated liquid. Similarly, to gain this energy, water must be circulating around the condenser. So that water is gaining heat. Okay. So here also you can see there is a temperature difference. And this temperature difference is again resulting in external irreversibility. So not only on the boiler side, but also on the turbine side, there will be irreversibilities. And due to this irreversibility, the cycle which we were expecting to be an ideal cycle will not act as an ideal cycle, and hence loss. So primarily I have discussed two things with you. The first is the internal irreversibility, which happens due to friction in the turbine pump as well as in the line, and the second one is the external irreversibility, which happens on the boiler side as well as condenser side, and that is due to the temperature difference between the working fluid. What is the working fluid? Water is the working fluid, Okay, and the secondary fluid which is supplying energy, that is air, that is not air, sorry, flue gas. Hmm, flue gas on the boiler side, and the cooling water in the condenser side. So now you know the different types of irreversibilities. In the next lecture, I'll tell you about the Carnot cycle, and why the Carnot cycle is basically not applicable in case of your steam turbine power plant. So in this lecture, till this point only. Thank you very much.